Okay, so in this next video for part 2 of 2.1, we're going to continue with another example of completing the square. In this one, we have a function, f of x is equal to x squared minus 4x plus 3. And we want to go ahead and sketch the graph, identify the vertex, and find the x-intercepts as well. So we have one more kind of step for this one. Okay, so to find the vertex, we're going to go ahead and complete the square. The great thing about this one is that if we see here from the way beginning, okay, right here, a is equal to 1, so that's awesome. That is a good thing because we don't have to worry about dividing by a and then multiplying a back in. So it's going to save us 2 steps. Okay, so let's go ahead and focus on this part first. So to find the vertex with completing the square, our first step is to set that equal to 0. So 0 is equal to x squared minus 4x plus 3. Okay, there's no a, so we don't have to divide by anything in this one. So for our new step 2, we can go ahead and move the constant right away. So minus 3 from both sides in this case, which is negative 3 equals x squared minus 4x, and now that is gone. Next comes our most important step, which is the actual completing the square part. So we are going to add b over 2 squared. That's one you might kind of want to memorize. Add b over 2 squared to both sides. This would probably be the last time I actually write this out. Okay, so in this case, before we do that, we need to actually calculate b over 2 squared. So our b over 2 squared in this case would be that negative 4. Okay, so negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. We still have to square it, so we come out to positive 4. Okay, so we're going to add positive 4 to this side and to this side. So let's go ahead and do that. So I'm going to have negative 3. I'm going to move this up just a little bit. Plus 4, so there's that square, equals x squared minus 4x plus 4. Okay, so there's my addition of b over 2 squared to both sides. Step number 4 now is to combine and factor. So I'm going to combine these two, which gives me positive 1. And I'm going to factor this part. So if I did this correctly, I should have the same exact binomial here. So I know that to get 4, I can do 2 times 2. But since it has to add up to negative 4, they're probably going to have to be negative. Let's see, negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So we're good to go with this. Okay, I just have to rewrite it in a square format. So like this. Okay. Step number 5 is to move the constant back over. So I'm going to go ahead and do that next. I'm going to subtract 1 in this case to move that constant. And that gives me 0 is equal to x minus 2 squared minus 1. We're almost done. Normally, if you had an a that was not equal to 1, here's the part where you would multiply that back in. But since we don't have an a, we can actually just rewrite this as our function. So f of x is equal to x minus 2 squared minus 1. And that means that this already gives us our vertex, so we can get our vertex straight from here, which is going to be positive 2 and negative 1. Remember, we just get it from our h and our k, which in this case is this guy and this guy here. Okay, if I wanted to find the axis of symmetry, I didn't ask for it, but I mean, it's not that hard to find. Our axis of symmetry, or AOS, would just be the same as that x value. So x is equal to positive 2. Okay, so that gives us the vertex and the axis of symmetry. So I'm going to go ahead and sketch that so far. I'll do that here at the bottom so I can add the x-intercepts in a bit. So 2, 2, -1, so 1, 2, we'll put 1 right there. So 2, -1 is about right here. Okay, my axis of symmetry is going right down the middle at x equals 2. And I know that the graph is going up because a is 1 and it's positive right here. But I'm going to go ahead and wait for that because I'm going to find the x-intercepts. Okay, so for the next part, I'm actually going to show you how to do it using, actually not that one, this one right here. Okay, and actually you could even possibly use this one. So whichever one you want to use, you'll kind of see how it works. So when we're completing the square, what we can do in addition to finding the vertex is find the x-intercepts. So I'm going to go ahead and come back up to this side here. And it says to find the x-intercepts, try factoring. If not, finish by completing the square or a quadratic formula. So I'm going to do this one just to kind of show you how it works and because it goes with the problem. So I'm going to pick actually the last one that I circled. So this at this point right here, okay? When you get to step number 4 or whatever step it is, depending on if you had an A or not, okay? You can actually find the x-intercepts at this point, okay? To do that, we're just going to solve. So we would just solve for x at this point. So think of it like a regular equation. Okay, you would square root both sides, right? So that's going to give us on this side plus or minus 1, or you have to consider both, is equal to x minus 2. And then the next step would be to add 2, right? So we would do plus 2 plus 2. So x is going to be equal to whatever this is. Now, the only thing you have to be careful about here is that there is a plus and a minus. So you kind of have two different cases here, okay? You have x equals positive 1, so 1 plus 2. And then you have x equals negative 1 plus 2. So just be careful with that because you have to include both of them, okay? So for the first one, 1 plus 2 would be equal to 3. And for the second one, negative 1 plus 2 is just going to give us 1. And those would be our x-intercepts. Simple as that. So you can see that computing the square does kind of have its advantages. You can kind of do all this in one process. Let's go ahead and add that to the bottom here. On our graph, we have 3 and 1. So, okay, so there's my 1, there's my 3. There are my points. And my graph looks something like that. Okay, nice and concave up. Vertex is at 2, -1. It's a minimum, by the way, which we're going to talk about in a little bit. And then we have our axis of symmetry down the middle. Okay. Just to kind of even push more the point that this is correct, if we did try factoring, so this is kind of an extra, but it's good to know. If we had factored since the beginning, remember that the function was f of x is equal to x squared minus 4x plus 3, okay? If we factored, well, all we have to do is set it equal to 0, and then we find the two binomials that when multiplied give me this. So it would be x, and then we have -3 and -1, because those two multiplied give me 3, added they give me -4. When we set them equal to 0, okay, you're going to see that x comes out to 3, and then this side, x comes out to 1. So it checks out. The last method would be quadratic formula. I'm not going to do that in this video. If we do come upon it, I can definitely make a video to review that concept in case you forgot the formula, okay? But that's it for this problem. Let's go ahead and move on. So now we have example number 5, and this one's a little bit, I think it's a little bit easier. So now we're going to write the actual function given different parts of the graph. So it tells us here the standard form of write the standard form of the quadratic function, whose graph is a parabola. So we know it is a x squared type of problem with the vertex -411, and that passes through the point -615. So what I'm going to do for this one is I'm going to use the standard form, which is f of x or y equals a times x minus h squared plus k. And we're just going to plug everything into where it goes. Okay, so let me color coordinate it just a little bit. I'm going to go ahead and do my x in purple and also my f of x. Remember, f of x is the same as y, so if you want to put like a y in front, that's fine too. And I know that my vertex, okay, is going to be the h and the k. So it's the h and the k, okay? So in this case, my vertex is right here. So this is going to be my h. This is going to be my k. And the point that it passes through, this one, I'm going to use this as my x and my y. And all I'm going to do is plug everything in, because if I plug all this in, I can solve for a, and that's the only letter that I actually need here, because h and k are done. They're right there. I could just plug them in and we're almost done. We just got to find that the value of a, okay, our stretch or compression. So let's go ahead and do that. We're going to plug everything in. So y equals, in this case, 15, okay? So 15 equals a, I don't know what a is, okay, our x. So our x in this case is -6. So -6 minus our h, which is -4. Be careful with the h because we know it's the opposite, but you're going to see here that these two are going to turn that into a positive. So that's where that plus comes out and it becomes opposite of this, okay? And then plus k. So plus 11 in this case. So again, just take all these four numbers, plug them in where they need to go, okay? And then we're just going to simplify. So it's just a matter of combining like using PEMDAS, okay? So in this case, I know that 15 is the same on this side. I'm going to do the middle part here first. So I have -6 plus 4 because of those two negatives, okay? Squared plus 11. I'm just going step by step here. A -6 plus 4 is -2. Bring everything else down. We're almost done. 15 is equal to a times -2 times -2, because that's what the square means, is going to give us +4. Be careful because we like to leave it negative, but it's not. Anything squared is positive. Okay, plus 11. We're almost done. Let's subtract 11 from both sides. 15 minus 11 is 4. We wanted to get a by itself to solve for it, so in this case we divide both sides by 4. So a is equal to 1, which means there is no vertical stretch, no vertical compression, it's just 1. So our equation would be f of x equals 1 times x minus -4 squared plus 11. So right here, this is our h, this is our k. Okay, we no longer need the points, we just needed them to find the a, okay? And then from here, you would just make this look nicer because that looks really weird. So I would probably get rid of the 1. I would definitely combine those two, so it's going to give me that +4 and plus 11. And you can see that that opposite thing I was talking about kind of happens by itself. So now we know from here that the vertex is -4, 11, which is exactly what I had up here. Okay, almost done, guys. Last part of this is going to be, and I think this is actually, yeah, this is the last one. So it's nice and short. Minimum and maximum values. We already kind of talked a little bit about this in a previous video. So just copy this down. We have a short example. It says if f of x is equal to ax squared plus bx plus c, then when a is greater than 0, in other words, when a is positive, f is going to have a minimum at this point right here, x equals negative b over 2a. And I think we might have seen this in a math lab, so it shouldn't be too unfamiliar. Pretty much this is the formula to find that x value, okay? The minimum value, the actual minimum value, so the y value, okay, is going to be f of whatever that is. So if this answer is like a 1, to find the y value, you take this value and plug it back into the function. So it's just plug it in to get the y. Same thing with the negative side, except it's negative. Okay, so the formulas are the exact same. Okay, you just have to be able to identify if it's a min or a max. So we're going to have a really quick example. You can see there's not even that much space because it's so quick. It says to find the min or max values for f of x is equal to x squared minus 4x minus 5. So what we're going to do first is identify our a. So our a here is equal to 1. Remember, it's the number that's right here, but there's nothing there, so there's that imaginary 1, which is greater than 0. So that means that this graph is going to be going upwards. Okay? It's positive, so it's going to be up. And if it's positive, according to what I have up here, that means we're going to have a minimum value. Okay, so just keep in mind that this is going to be a min. Okay, then we're going to go ahead and actually find that point. So x equals negative b over 2a. So in this case, our negative b is going to be this 4 right here, but it's negative, so we kind of have to do like a double negative. We have negative and then negative 4 over 2 times our a is just 1. Okay, if you need to put the letters, you can. Okay, this is a, I'm sorry, that's b, this is a, and this is c. Okay, and we just simplify this, so we end up with positive 4 over 2, which is just 2. So the x value is going to be 2. Okay, to find the y value, we're going to plug in f of all of this, which is the same as this. So f of negative b over 2a is the same as f of 2. And you have done this before. So all we're going to do is take this number, and then we do a little bit of color coordinating here. So that's squared minus 4 times that minus 5. So I'm just getting this directly from this example here. So I'm going to take whatever I need to plug in and plug it into those parentheses. Okay, it's coming directly from the function. So 2 squared minus 4 times 2 minus 5. This looks like it's going to be, let me move this just a little bit down. 2 squared is 4. Okay, I'm almost out of space here. Minus 8. 4 times 2 is 8. Minus 5. Okay. 4 minus 8 is negative 12. Negative 12 minus 5 is negative 17. Hopefully I did my math right here. So that means that the y value is negative 17. So together, this means that our minimum is at 2, negative 17. Okay, so just really quickly, this was going to be kind of hard to graph because it's kind of a, that's kind of a low point. So 1, 2, and we'll just say this is negative 17. So that graph is way down here somewhere, with the point anyway. And it is going up because a is greater than 0. And we are done. Okay, if you have any questions, as always, let me know.